S K Pandey. I am in the research person of Gyan Asthali International School. The topic developing scientific temperament. Developing scientific temperament. And topics, subtopics of developing scientific temperament is scientific temper, flow of presentation, concept of scientific temper, importance of scientific temper, developing scientific temper, and last one is conclusion. So the first one is what is scientific temper? The scientific temper, a term coined by Nehru discovery of India, means scientific attitude of questioning and being open to question. That means evidence-based reasoning, not accepting received wisdom by justification. All natural and social phenomena must have material, not supernatural explanation. Fifth one, science, that is the natural and social, is the heterogeneous understanding of reality, with many aspects yet unknown, and better understanding is possible and should be pursued. Every theory answer raises first question. For inquiry in science, there is no ultimate truth where inquiry stops. And last one is critical thinking best described of scientific temperament. And next one is scientific temperament means you must be already beginning. You must be already beginning to feel that the scientific method is in fact mainly being applied by most rational and logically minded people even to solve everyday problems. What do you know? For example, when your television screen suddenly goes black, you collect all the information pertinent to the phenomena, the state of cable connection at the TV and outdoors, whether this blank screen appears in all the channels. Is there audio failure too, or only video failure, any abnormal heating inside the television, etc. Based on this observation, you hypothesize there is electricity failure at the cable transmission office. To verify your hypothesis, you telephone the cable operator and that confirms the cause of the problem and assures that it will be sorted out within a few minutes. Thus, all the steps of scientific method are involved in the process of solving this commonly encountered problem. We consider such a person who imbibes the essence of scientific method in his outlook and uses it in his everyday life as possessing scientific temper. She may not necessarily be a scientist, not even a science student, and yet have scientific temper. This scientific temper or scientific attitude is characterized by the following traits. The first one is healthy escapism, universalism, freedom from prejudice or bias, and objectivity. And last one, viewing this the perspective, scientific temper becomes an attitude, a way of life. That is the scientific temper. And second one is flow of presentation. The flow of presentation, some topics are described in front of you. The flow of presentation is scientific temper, the role of scientific temper, importance of scientific temper is already enclosed. How to develop scientific temper? Why is scientific temper important? 6 pillars of scientific temper: scientific literacy, scientific attitude, scientific thinking, all are the flow of presentation. scientific method, scientific perception, scientific habit, conclusion and references are the knowledge flow of presentation. The next one is concept of scientific temper. Concept of scientific temper. The major aim of science education is to develop scientific attitude among the learners in proper way. Let us first look at the two terms mentioned here, scientific attitude and scientific temper. These terms are used interchangeably in field of science and encompass similar traits or features that are required to be developed among learners through science teaching. Attitude can be defined as mental predisposition towards people, object, subject, event and so on is the concept of scientific temper. And next one is importance of scientific temper. The importance of scientific temper is scientific temper will lead to develop attitude of questioning and reasoning in every citizen. Such attitude will boost countries' techno-social development. Scientific temper made human understand there is reason behind every happening. This reason can be understood by human. The efficiency of approach and ability of right resources will decide time, competence and correctness of explanation. And lastly, this is the best way to obtain the correct explanation for unknown happening. This is the importance of scientific temper. Now, that is the check out the techniques, the basic step to scientific method making a hypothesis to explain certain observation and verifying the prediction of hypothesis against. Carefully obtain experimental data, however, remain unaltered, although the instruments that social scientists use to do not yield the same degree of precision as in physics or chemistry. It is not the precision that makes a discipline scientific, but the methodology by which theories are generated and tested. This is the known and importance of scientific temper. Check out your progress of importance of scientific temper. What are the main ingredients of scientific method? What is the difference between induction and deduction? What care is necessary while observing a phenomenon? Some example to illustrate how scientific theories have been suppressed and modified with advancement in knowledge. This is the progress of importance of scientific temper. Now, modification and rejection of hypotheses. When the prediction of hypotheses are not in agreement with experimental finding, the hypothesis may either be rejected as a description of the phenomena or modified till its prediction tallies with experimental observation. There are numerous instances in history of science where prevailing theories were rejected in the face of experimental evidence. Thus, the geocentric model of planetary system was supplanted by Copernican heliocentric model through experimental observation of Kepler and Galileo. Later, this model was modified with its circular planetary orbits replaced by elliptical orbit, which could eventually be derived from Newton's law of mechanics. Similarly, the concept of hollow system, the substance with negative weight which escaped from a body when it was worked, was given up as light of precise experiments of television to show that during combustion the mass was conserved. Although matter may undergo ignition, there is no change in its mass. The classic example of how hypothesis is modified in the light of prediction disagreeing with experiment is the method followed by the Galileo, one of the harbingers of modern scientific method in his study of falling object. On the basis of this primary observation that falling object move with constantly increasing speed, he formulated a hypothesis that the speed was proportional to the distance traversed. He was not able to test this hypothesis directly proportional to the time left. The hypothesis led to the prediction that the distance traversed by an object is proportional to the square of time elapsed, which he verified experimentally by studying balls rolling down an inclined plane. The practice of scientific method, you would have realized from the above description of the scientific method that its main objective is to eliminate as far as possible the influence of scientific predisposition of bias. On deriving conclusion from the study of a phenomena, scientists also, like all human beings, have certain likes and dislikes which could influence judgment in many ways. Example, preferences or even attachment to a particular scientific theory, and aesthetic sense which prefers simple or beautiful formulation over complicated ones, or even personal or cultural belief like God does not play dice, which was a cryptic comment of a great scientist like Albert Einstein. On the probabilistic explanation emanating from quantum theory, this is also ensured to a great extent by the practice of peer review of the scientific findings before their publication in scientific journal. Here, a panel of fellow scientists without revealing their identity is known as the exams of claims made and the process followed in arriving at this level, and gives its comments to the author. This open communication among members of scientific community, together with the possibility of experimental study being repeated at different places, ensure that individual bias is eliminated and a consensus developed in the community about the validity of scientific theories. You must, however, appreciate that there is an element of subjectivity involved in the process of induction of a hypothesis from the observation. There are numerous stories of scientific struggling intellectually to make sense of the observation of certain phenomena, only to that reveal the hypothesis in a flash of inspiration in the most unusual manner. Archimedes is said to have discovered the law of rotation while walking in the thought, and acclaimed Eureka James Watson discovered the shape of DNA molecule after he decided to where a snake was catching its own tail. However, the final acceptance of theory is not based on the account, howsoever interesting there be, nor on the authority of the scientific. Howsoever reduced they may be, any scientific theory is accepted only when its prediction can be experimentally verified by one and all. This, of course, demands that experimental data be collected properly. The methodology of data collection be revealed and the degree of uncertainty in measurement be quantified. It is also presumed ethical uprightness in that no experimental data should not be rejected just because it does not fit and hold. There exist numerous examples in the history of science where, due to absence of big checks and balances, scientific community had to face great embarrassment. The most recent example is the cold fusion experiment of bones and placement. Reportedly performed at the University of Patna in 1989, all subsequent attempts at application failed, calling into question the original work and eventually purpose. And placement redirected their funding and resent their university post. On the other hand, there are also some interesting examples where the apparent anomalies in data have led to path-breaking prediction. For example, the path of the orbit of Uranus is not in tune with the prediction of Newton's theory of gravitation. Eventually led to the discovery of another planet, Neptune. It is also important to appreciate that the far step to scientific methods are applicable to all the sciences, whether this be the so-called exact science like physics and chemistry, or the more descriptive science like geological, anthropology, and psychology. The only difference is the nature of experimentation and the data collected. In the exact sciences, physics, chemistry, the data are in the form of numbers. For example, the weight of in kilograms, the charge in coulombs, the electrical potential in volt, the temperature in Kelvin, etc. All of which are directly read from certain measuring instruments. In social science, the instruments are often questionnaires, case studies are interviewed, notes from which inferences have to be derived, often by using a statistical, the notion that when we have traced a law, we have discovered an ultimate cause. Scientific theories are essentially creative generalization of great practical significance which put together a conceptual model of nature, but which cannot unravel the imprecise measure of reality. Now the next topic is developing scientific temper. The developing scientific temper in our country, where a large section of the society is still caught in the community of superstition and overscripting practices, inculcating scientific temper, even the citizens is of paramount importance for development of the nation. This is best done during the childhood, while the child is learning how to respond to the agonies of everyday life. It is therefore essential that the school curriculum should respond adequately to this important need. This demand includes inculcation of values like a spirit of inquiry, courage to question, objectivity, honesty, and truthfulness, which are precursors to the development of various traits characterizing scientific temper. The spirit of inquiry, so natural in most children, actually gets stifled by the trap teaching learning environment created by the deductive teaching methodology. Even learning of science, which should be a joy of discovery, becomes a burden memorizing so many facts. Formula, chemical reaction, etc. It is therefore of paramount importance that education process be made careful with the teachers acting as facilitators of learning as friends and made joyful with the teachers acting as facilitators of learning as friends and guides. The child must be free to learn what he chooses to at the pace that he realizes and must be free to make mistakes without the fear of being reprimanded by the teacher. There exists numerous success stories of a school where education is imparted by the variety of means like story, painting, recitation, games, group project, self-reading, etc. so that the child is eager for learning does not diminish. In such schools, the children are not afraid to ask a question from their teacher friends, and thus their inquisitiveness of strengthened. An effective method of fostering scientific temper is imparting knowledge of science through experimentation and demonstration. By involving a student directly in activities similar to how scientists operate in discovering new knowledge, this is usually referred to as a discovery approach to teaching and eminently suited to teaching science. Train and Son gives numerous examples of discovery relation for a variety of sciences: physical science, earth science, biological science, wherein there through simple experiments the student discover for themselves various scientific concepts. I give some approach simple to such a popular discovery activity taken from their book, which indicate how the various steps which are a part of scientific method get integrated in such a simple experiment. Clearly, teaching of science in this manner would greatly develop scientific temper among the students, for as goes the Chinese proverb: I hear and I forget, I see and I remember, I do and I understand. To inculcate scientific temper among the students, they need to be placed in situation through role play, quizzes, model making, etc., where critical and rational thinking are needed. We also need to make them aware of the impact of techniques. The basic aspect of scientific method, making a hypothesis or to explain certain observation and verifying the prediction of the hypothesis against carefully obtained experimental data, however, remain unaltered. Although the instrument their social science it do yield the same degree of precision as in physics or chemistry. We not the precision that makes the discipline scientific, but the methodology by which theories are generated and tested by developing scientific temper. Now, the practice of scientific temper would have relied from the above description of scientific method that its main objective is to eliminate as far as possible the influence of scientific prediction of bias and deriving whether from the study of the phenomena. Now, the developing of scientific temper is the overview in this unit. We shall understand the essence of scientific method, the characteristics of scientific temper, and the method by which you can develop scientific temper among the students and teachers in the school. We shall also understand how scientific method can be extended to all aspects of everyday life, including a spiritual pursuit. Some objectives of developing scientific temper. After studying this module, you should be able to explain the essential feature of scientific method, define the characteristics of scientific temper, identify the strategy for developing scientific temper among the students at various levels of a school education. Apply the scientific method to all aspects of everyday life, including spiritual pursuits. Now, some inequalities of fundamental fate of human being. From times immemorial, man has tried to comprehend the world in which he finds himself. The knowledge gained through observation of natural occurrences like apparent movement of sun, moon, and other heavenly bodies, storms, and lightning, eclipse, and meteorology, growth, and properties of clouds. Was gradually systematized and classified, and the process of identifying causal relationship was initiated. The roots of modern science and scientific method can be traced to the early attempt to relate cause and effect. On full moon, nights the waves in the sea were always higher than on moonless night. Eating certain plants always induced intoxication. A stone thrown at a certain angle of inclination traversed the largest horizontal distance, etc. Another crucial step was identification of patterns in observation. Full moon nights and moonless nights occurs at a regular period. There was noticeable predictability and a pattern in occurrence of weathers. Rains always written and pattern of occurrence of weather. Rains always followed summer, winter followed rains, and spring followed winter. Many plant protesting the weather. The summer certain regions proliferated only in summer and others during monsoon, etc. Repeated observation of such patterns and causal relationship lead to induction of generalization of theories, many of which were often raised to the status of laws of science. Once the deduction from these theories were experimentally verified repeatedly. This in essence is the process by which even modern scientists progressively understand that nature better, thus may be asked to harness its potential for the welfare of humanity. The scientific method can be seen as comprising of 5 steps, that is an intensive observation of the phenomenon, understanding with the view of identifying the various parameters influencing it and any causal relationship between these. Formulation of a general hypothesis to explain the phenomenon. This hypothesis could be some kind of causal mechanism or even a mathematical relationship between the variables influencing the phenomenon. Using the hypothesis to make prediction about the existence of some other phenomena or about relationship between variables derived from mathematics and logic. And the next problem is verifying this prediction by performing carefully controlled experiments. If the experiment validates the prediction, the hypothesis is accepted as a theory or even a law of nature. When its predictions are confirmed through repeated experimental tests. What if the experimental results are at variance with the prediction? The hypothesis is either rejected or modified. Some of the structure of predictive result relationship between the deduction and the verification, larger reduction and the experiment to verify the of scientific method and Now, the observation. The scientific method demands that the observation be carried out in a systematic manner, taking due care of ensure that it is free from any bias and experimental errors. Often the observation involves measurements, always some uncertainty associated with these arising from the instruments used for measurement, like weighting belt, thermometer, titration, equipment. These can be quantified and need to the clearly stated to avoid various confusion. Uncertainties may also arise from the presence of uncontrollable factors influencing the phenomenon under investigation. And deep care has to be taken to eliminate these. This is especially true in studies involving living organisms, be it plants, animals, or human beings. The nature of these instruments are, of course, different in social sciences and could take the form of interview, notes, case study, questionnaire, etc., and show the degree of precision of comprehension. The hypothesis and prediction. The hypothesis and prediction of developing scientific temper is the different scientific temper is the cooperation concept of scientific temper and the importance of scientific temper is very important in our future, in our society, in our culture of our Indian phenomenon. The hypothesis is the formulation of an hypothesis to relate the various variables observed to explain the phenomenon mostly and creative act. An act of initiatives insight and thus not easily amenable to description of hypothesis. The most important characteristic of scientific hypothesis is that it should be verifiable rather falsifiable. Thus, the hypothesis that magnetic substances contain young angles who get attached toward the ferries contained in magnet. But these angles and ferries cannot be seen by humans is not testable since the angle and ferry are so designed that we can never see them. It is therefore not a scientific hypothesis. On the other hand, the hypothesis there are no young angles in magnetic substances is testable. One can falsify it by catching one such angle. Similarly, the hypothesis that light made in the strong gravitational field is verifiable and even suggests measurement that can be made to test falsify the theory. Now, the next one is prediction. The prediction of power is review of hypothesis lies in its ability to make prediction about phenomena other than the one which forms its basis. For example, Newton's hypothesis regarding relationship of gravitational force of attraction between objects could be used to make such diverse prediction as the phases of the moon, the phases of Venus, and our maximum tide in the sea. All these predictions were verifiable. Similarly, Einstein's formulation of the hypothesis of relativity predicted that a clock inside a fast moving spaceship would slow down as compared to an identical clock on Earth. It took almost 50 years before this could be experimentally verified and give credence of this hypothesis. The other astonishing outcomes of the theory is equivalence of mass and energy are also verified much later in practical physics. The prediction from a hypothesis may be made using logic or where the hypothesis is mathematically formulated by mathematical tools, as was the case with gravitation and relativity. Now, next one is verification. The most crucial aspect of the scientific method is verification of the prediction of the hypothesis by performing suitably controlled experiments. The need for control over the experiments is of paramount importance since otherwise random chance factors can force us to draw wrong conclusions. Many of the so-called superstitions in various societies are associated with some previous cause affected association noticed in some random observation. Thus, a cat crossing the road or someone asleep before you leave the home being wet once the number 13 being unauspicious etc. are said to be superstition since the hypotheses have not been established repeatedly in controlled experiment. The difference between a superstition and a scientific theory essentially lies in the repeated verifiability of the latter in pre-planned control experiment. Thus, while testing the efficacy of drug, the doctors need to ensure that the effect observed are indeed due to the drug and not due to some random chance factors. Thus, is usually done by talking to two groups of patients. One group is given the drug under test and the other is given to placebo. That is a look-alike pill of some common substance like milk or sugar. Without the patient knowing about it, statistical techniques are often employed to ensure that the observed difference between two groups is significant to a high degree of probability so that the conclusions are not distorted by experimental research. You must also be cognizant of the fact that process of verification is always tentative and within a certain domain of experimentation there is no way that we can prove any hypothesis for formal proofs are possible only in mathematics. In fact, we cannot even truly verify a hypothesis. We only fail that refute it. The history of science is replete with examples where some hypotheses relate to the status of laws of nature. After repeated verification, were seen to be limited applicability in the light of new finding over wider domains of data. The most notable example is that of Newton's law of mechanics, which we now are very only when the velocity involved are less than the speed of light. Since the domain of human experience involved velocities were much larger than the speed of light, the laws of mechanics got repeatedly verified before Einstein brought in the relativistic formulation. Yet that verification did not lend validity to these laws, much less prove them. And we now know that these laws do not give an accurate description of the principle governing the universe. Thus, we need to bear in mind that the definition of all scientific theory, it is in fact not proper to call these as laws of nature, since as pointed out by Dampier, the word law imparted a kind of moral obligation which made the phenomena of a law and led to. We shall discuss each of the state with some detail of the analysis of scientific matter. This is the main conclusion, main view of the developing scientific temper. Now, the developing scientific temper is most important that the overview, concept, importance of scientific temper, developing and scientific temper is the part of different types of attitude, different types of scientific temper. The importance of scientific temper, as we know that the scientific temper will lead to develop attitude of questioning and reasoning in every citizen, certainly to be both country, techno-social development. Scientific temper makes human understand there is reason behind develop happy. This reason can be understood by human. And the most important is that the concept of scientific temper is the major aim of scientific education is to develop scientific attitude among the learners in property. Let us first look at the two terms mentioned here, scientific attitude and scientific temper. These terms are used interchangeably in the field of science and encompass similar traits of features that are required to be developed among learners of science technique. Attitudes can be defined as mental predisposition toward the object, subject, and event. The scientific attitude of question can be open to question. Evidence of reasoning based of this the all natural and social phenomena must have material, not supernatural explanation. Science and natural, yet unknown and bigger understanding is possible and should be pursued. Every theory answer will face question for inquiry in science. There is no ultimate truth where inequity is stopped. The critical thing is best is that in scientific temper is that when the prediction of hypotheses are not in agreement with experimental finding, the hypothesis may either be rejected and the description of the phenomenon are modified till its prediction telling experimental observation. There are numerous instances in the history of science where the proven theories are made. Thus, the geoscientific model of planetary system was supplied and the secure progress is that check whether the following are scientific hypotheses The Mars is inhabited by a spherical and creatures who can read our mind and will hide whenever anyone in Earth looks at them or any spacecraft comes near. The amulet given by that saint can cure cancer. All matter turns into wave when no one is looking and then turns back if anyone looks. Find out from internet surfing. Some case studies are prevalent practices in science. What lesson do you draw from this? This is the check your progress of scientific temper. The scientific method is the observation, hypothesis, prediction, and verifying of different types of modification to conclude through the hierarchical diagram. The observation, hypothesis, prediction, and verification is the most important part of scientific temperament. The scientific temperament is the observation to this is the specific to in a study involving living organisms, be it plants, animals, or human beings. The nature of these instruments are of course different in social science and would take the form of written notes, case study, questionnaire, etc., and show the degree of precision comparatively. The hypothesis, the formulation of an hypothesis to relate the various variables observed to influence the phenomena is mostly a creative act, an act of initiative, insight, and thus not really amenable to description. The most important characteristics of scientific hypothesis is that it should be variable rather falsifiable. Thus, the hypothesis that magnetic substances contain young angles get attracted toward the varies contained in magnet. What these angles and theories cannot be seen by humans is not testable since the angles and theories are so designed that we can never see them. It is therefore not a scientific hypothesis. On that other hand, the hypothesis there are no young angles of magnetic substances is testable. One can falsify the catching one such angle. Similarly, the hypothesis that light bend to gravitational field is verifiable and even suggest measurement that can be made to test the claim. The prediction of power validity of the hypothesis is the most important, must also be the information that fact the progress of prediction is always tentative and within a certain domain of mathematics. There is no way we can prove the hypothesis for false. The scientific intensity of the phenomena under study with a view of identify the various parameters, various hypotheses, prediction, verifying, and the verification of conclusion of scientific temper. Scientific temper is the part of developing the flow of conservation, concept of scientific temper, and importance of scientific temper. The scientific temper is the most important fact we cannot even truly verify. A hypothesis we only fail if it refutes. The history of science is replete with examples where some hypotheses elevated to the status of laws of nature. After immediate verification, we are seeing of the limited applicability in the light of new findings over wider domains of data. The most notable example is that the Newton's law of applicability, which is now known valid only when the recipes of laws of mechanism create confidency reflected in our society. Now, some of the practice scientific you would have relied on the aim description of scientific method that is main objective is to reveal as far as possible the influence of scientific prediction or bias of the rising intuition from the study of phenomena. However, the final acceptance of theory is not based on these account, howsoever interesting deeply, nor authority of scientific, howsoever mirror they may be. Any scientific theory is accepted only when its prediction can be experimentally verified by one and all. This of the course demand that experimental data be collected properly. The methodology of data collection be revealed and the degree of certainty measurement to be quantified. It also presumes ethical uprightness in that no experimental data should not be rejected just because because it does not fit the theory. There exist numerous examples of history of science where due to absence of deep checks and balances, scientific community had a wasted investment. The most recent example is the cold fusion experiment of Holmes and Isman reportedly from the University of. On the other hand, there are also some interesting examples where the apartment technology data had to be parking and research. It is also important to appreciate that the five step, that is the last, is known as the conclusion. The conclusion of developing scientific temperament is when the prediction of hypotheses are not agreement. It is the scientific temperament of the science and technology to the data are in the form of numbers. For example, the weight in kilograms, the charge of Columbus, and electrical potential in volt, the decision in Kelvin, and the science instrument or the questionnaire case study to overall developing scientific temper is the most important. Is that the scientific temper flow of organization, concept of scientific temper, and importance of scientific temper, and developing scientific temper. The lastly one is the conclusion. Examine the claim made and the process followed in arriving at these claims and gives it comment to the author. This is the open importance of life, importance concept of scientific temper, flow of presentation, and that is the scientific temper developing means this is the different types of developing. It is also important to appreciate that the five steps to scientific method are applicable to all the sciences where that to be called exact sciences like physics, chemistry, or more discipline science like geology, anthropology, psychology. The only difference is the nature of experimentation data collected in the exact science is chemistry. The data are in the form of numbers, for example, the weight in kilogram, etc. Yeah, developing scientific temperament is the part of. Thank you. That's all for developing scientific temperament.